Hello, mathematicians. Today, lesson 1-2, we're going to understand whole number place value. I anticipate this to be somewhat of a review. You did this in fourth grade. The only difference now is that we are going to be looking at standard and expanded form. And when we write an expanded form, we're going to simplify it using the distributive property and exponents and your knowledge of exponents to simplify that in expanded form even more. So let's look at what we're going to be doing. So how are place value positions related? According to the US, according to the 2010 US Census, the population of Phoenix, Arizona is about 1,440,000. What is the relationship between the value of the two fours and the number? It says writing a number in expanded form can help. So before we get to that question, let's look at how they wrote this in expanded form. So when you are working on these problems, and if you can't remember your place value, the place value chart is your best tool to help and assist and aid you with that. So here is 1,440,000 in our place value chart, and they want to know the relationship between the two fours in this number. So here are your two fours, one in the hundred thousands place and the other one in the 10,000s place. So these two fours right here. And you know, because it's right here, it's times 10. Anytime that you are going from right to left from a smaller place value to a larger, it is times 10 because we're in a base 10 system. And it holds true if the two numbers are the same. I'll repeat that. Anytime you are going left from right to left in our base 10 system, you are multiplying 2 if the two numbers are the same. And I'm going to show you why. So look at this expanded form of 1,440,000. The value of the 4 in the hundreds thousands place is 400,000, right? So we look back here, this 100,000, you have 400,000. So 400,000. The value of the 4 in the 10,000s place is 40,000. So I have 4 here in the 10,000s place. 4 10,000s is 40,000, right? Count your 10,000s. 10,000 plus 10,000 is 20, plus 10,000 is 30, plus 10,000 is 40, 40,000. We know that 400,000 is 10 times as great as 40,000. And 40,000, on the other hand, is 1/10 of 400,000. You might be saying 1/10, why are you putting fractions in there? Remember, fraction is another way of saying it's a division problem. And if you put 400,000 and you divided that by 10, you would get 40,000. So 400,000 over 10 would give you 40,000. It's another way of saying dividing. So the 1/10 comes in the fact that if this is times 10 to go across from right to left, if you go from left to right, you are dividing by 10. So if I go this way and the digits are the same, I'm dividing by 10, or I'm just simply saying it's 1/10 of that value. Because if you had 10 40,000s, you would have 400,000. So it's 1/10. Showing you that as a bar graph, if you think about it. Should have had this prepared ahead of time, but this is a good point to make. One, two, three, four, five. Copy. Oop, I don't want the numbers with you. That's a mistake. If this is my 40,000 and each of these are, sorry, if this is my 400,000 and each of these are 40,000, shrink it down, you would have 10 of these to get to 400,000. So 40,000, 80,000, 120,000, 160,000, 200,000. This is 200,000, and we keep going until we get 400,000. All of these together, if you wanted to add them, would be 400,000, right? So if you have one of them, it would be 1 out of 10 or 1/10, because 10 out of 10 is 400,000. 1/10 is 40,000. And you could check my math on that if you want. So going back to this, you're going to start to see that now that you understand that place value relationship, it'll explain this expanded form a little bit better for you. So what I'm going to do is I'm going to clear this out so I have some room to show you this next. So you remember how to write this in expanded form. Remember when we write expanded form, we're pulling out each of these place values and we're writing the value and we're adding it together. So if we did this, we would have, so we have 1,440,000, we would have 1 million. Is that 1 million? Make sure I'm right. Plus 400,000 plus 40,000 and if you look in your thousands, tens, hundreds, and ones place, you don't have any zeros, so you don't have to write plus 0, plus 0, plus 0, plus 0. So that would be this number in expanded form the way that you have learned in form. I'm sorry, in 4th grade, not in form. So let's talk about why they have these exponents. So they're just simply reducing it again and using the distributive property. Remember that distributive property is where you can put these parentheses in, and that shows that this is a piece, that's a piece, and that's a piece. So looking at 1 million, if you wrote that as an exponent, it would be, your base would be 10, and your exponent would be 1, 2, 3, 4, 5, 6 to the power. Do you see how I used that first two numbers as my base? 1, 2, 3, 4, 5, 6, I counted my zeros. So you would say 10 to the 6th. And what they do is they put these ones here, so you know it's 1 times 10 to the 6. Honestly, 1 times 10 to the 6 and 10 to the 6 are the same thing. I would accept either answer. I'll repeat that again. 10 to the 6 is 1 million. 1 million times 1 is 1 million. It does not matter if you put that 1 in there, but for the sake of being consistent with Envision, I will do that. The next one right here, look at my first two numbers, is 40. Count my zeros, 1, 2, 3, 4, 5. 40 to the 5th. So I can do 40 to the 5th times 1. Oh, do you see what I did there? I made a mistake. And you know why I made a mistake? Because 40 to the 5th is not 400,000. Why is it not 400,000? I made the mistake on purpose. And the reason being is that when you are simplifying these numbers, you want them to be in 10. And why do you want them to be 10? Because we have a base 10 system. So you have to think now, if this place value here is 1, 2, 3, 4, 5, 6. That's 6 spots. That's the 100,000s place. 10 to what equals 100,000? So I know it would be 10 to the 5th, right? 10 to the 5th, because if I did 10 to the 5th, I would write my 1 and then put my 5 zeros. 1, 2, 3, 4, 5, because that's what this exponent is telling me. And that's 100,000. But we have 400,000. So how many 100,000s are in 400,000? 100,000, 200,000, 300,000, 400,000. Counted 4 times. So that is why they write 4 times 10 to the 5th. And then plus 40,000. We'll think about 40,000 again. How many place values if you had to write that as an exponent? 10 to the what? 1, 2, 3, 4th. 10 to the 4th is 10,000. You have 40,000, so it's really 4 times 10 to the 4th. It looks complicated and scary, like my handwriting, but it really isn't. You just have to take a deep breath, step back, and first write it, I would say, in the expanded form that you know very well how to do, and then start thinking about how you can take these extended powers of 10, these powers of 10s, remember powers of 10s ends in zeros, how you can write them as exponents, and then think about which number here you need to add to that exponent to make it the actual representation of the number. And if you did all of this math, you would get 1,440,000. It's a good way to check your work. Let me show you again without anything in front of us. So we have the number 102,200, right? 102,200. So let's write that in expanded form. We know in expanded form that would be, take the 1 in 100,000. So 100,000 is 100,000 plus nothing in the 10,000s place, right? So we have something in the thousands place. 2 in the thousands place would tell me I have 2,000 plus my hundreds place is 200. That says its name. Nothing in the ones and nothing in the tens. So that was great when you did that in 4th grade and you did that in 3rd grade. Now they want us to look at how do we simplify this even more using those exponents. So again, think about how you could put these in powers of 10. And what I mean by powers of 10, I mean 10 as the base and some number as the exponent. I'm going to put a little x there just as a variable. So some number, question mark, so you know that we're thinking of a number. So what would be 100,000 as a exponent with a base 10? Well, if we think about it, wouldn't it be 10? So there's my 10. How many zeros? 1, 2, 3, 4, 5. 10 to the 5th. You can practice that. Rewrite 10 to the 5th if you have to. 10 to the 5th. We put my 10 down, and we have my 1 down, and my 5 zeros. 1, 2, 3, 4, 5, right? 100,000. You have 1, 2, 3, 4, 5 zeros. That's my exponent. If you did 10 times 10 times 10 times 10 times 10 times 10, you would have 100,000. Correct? Think about it. I would agree, right? All right. So now let's look at, we have 10 to the 5th times 1. So it's the quantity. We read this as the quantity. The quantity of 10 to the 5th times 1 plus 2,000. Well, how many thousands are in 2,000? There are 2, right? So the quantity would be 2 times that exponent that shows me 1,000. Well, 10 to the, I'm assuming, 3rd is 1,000, right? So 10 times 10 is 100, times 10 is 1,000. If you look, you have your 3 zeros there, just like your exponent shows. You have your 1, and then your 3 zeros, 1, 2, 3. So 2 times 10 to the 3rd power. So we have the quantity of 10 to the 5th times 1 plus the quantity of 2 times 10 to the 3rd plus the 200. So how many hundreds are in 200? You said it, 200, right? Here we go. So we have 2 times, and then 100 would be 10 squared, or 10 to the second power, right? 10 squared equals 10 times 10, or 100. Or you could do it the way I taught you here with that 1 going down and then your 2 zeros. That is version 1. This is version, well really this is version 1. This expression is the same as this expression down here that we just wrote. There's another way that you could do it though, and I want to show that to you, and I'll do it in red. You have how many hundred thousands? 1. So you could say 1 times 100,000. And I like this way too. So the quantity of 1 times 100,000 plus how many thousands do you have here? 2. 2 times 1,000 plus the quantity of how many hundreds? 2 times 100. All of these expressions will get you the same answer. We're not going to worry about number names now, but what I want you to know about number names is if you have a hard time writing the number names, use the place value chart. Use the place value chart. So let's look at that. 102200, right? 102200. And these are called, these lines here are called the periods. So you have your ones periods, your hundreds, and then your thousands. And why you have these in periods is that's how you read these numbers. You look at each period, and that's what you'll say the number within the period, and then move on to the next period and the next period. And I'll show you what I mean by that. Look at your thousands. You have what number here? 102 in these 3 blocks. Oh gosh, the fun of digital learning. 102,200. See that? 102,000, you say, and then the next one would be 200 because it's in the hundreds period. So you say just 200. 200. All right, friends, let's try that together today. I wish you luck, and we will see how it goes. I will be here to support you. You can write them in either way. I would like you to move beyond this method. You're going to have to do it as the first step, but you can try the blue or the red way, and I will leave this up here for you to view when we're going through the lesson. Good luck, mathematicians.